Now that I have my shelf documented and logged all the books, a wonderful subscriber asked me for a video on this book. I was planning to make this video a lot later because I wanted to have a little knowledge of some of the contents, but now it's as good as never. I mean, it'll be a long time before I can understand algebraic geometry, and this book is fantastic because it's for undergraduates. So ideals, varieties, and algorithms. And so it's got a computational aspect. It's one of these books like when you take calculus, they don't tell you everything about point set topology, right? So it feels like that. It feels like a calculus book that doesn't go into analysis, the same as a computational book in algebraic geometry and commutative algebra that doesn't have those fields as prerequisites, which is wonderful, right? And it says it right here, and I'll zoom in as I always do for the preface, or preface, as some people correctly pronounce it, and I don't. Okay. Yeah, so it's got computational aspects of two fields that require many prerequisites, but this book doesn't require them. Okay. And right here it says it. The prerequisites is just linear algebra and proofs. That's very early. There are appendices for Maple Mathematica and Sage, and I'll show all of that. Okay, so I'll put this in a way where you can read it. You can pause it and read it. Okay, but I'm not going to read it myself. Yeah, that way you can see all the contents in detail. I thought the book was bigger than Linear Algebra Done Right by Axler, but it is not. It's got more pages, but it's the exact same height. So it feels bigger because it's thicker, but it really isn't. And then the acknowledgements. And then I'll zoom out. There we go. Okay, so contents. I'll just show them, and I'm not going to read them because it's a lot of content that I'm not familiar with. And I will show briefly Gröbner, and I'm mispronouncing it. Somebody may help me in the comments. Gröbner basis, which is really one of the core concepts, is explained in Dummett and Foote in section 9.6, page 315. And so, and they even have examples. They even have examples of how to calculate them. And more and more examples. Yeah, many examples. So that's something that I would work through this book only after I have done this material and Dummett and Foote. That's just me. Look at how many problems. Oh, I love this book. All right, so back to this book. Yeah, elimination theory. I said I was not gonna name them, but yeah, it just go through a lot of concepts in commutative algebra and algebraic geometry without having to have all the machinery in gory detail, and it's aimed at an undergraduate. It's got a lot of problems. I started counting and I stopped, but it does have a lot of problems. The proofs are, well, are not super tight, which I like. I like it when the proof is wordy. Yeah, I think if I get a chance to try to teach myself some commutative algebra after Dummett and Foote, this would probably be a book that would follow it. And of course, all this material, I think I was reading through the ideal section. I personally I'm glad that I understand about ideals from Gallian, from abstract algebra. I don't know, it's just me, but it feels like this material would be a little hard for someone who doesn't know what the ideals do. I would be coming into this book with more prerequisites, and I like that. Pseudocode. So it's got a computational aspect. I mean, the core of the book is computational aspects, which I love. And in my case, I would actually use this book as my analysis of algorithms example, one of them. Yeah, so it has a whole chapter on Gröbner basis. Very detailed with proofs and calculations. Again, it just needs linear algebra and proofs. That's amazing that they pull this off. Oh, look at all those beautiful polynomials getting divided. I love that. I love polynomials. Nice pseudocode. Yeah, I would definitely use Mathematica or Maple, maybe like get the student version of Mathematica to run through this book. I think without, and I'm going to name Mathematica because it's the one that I would get. I think it's affordable enough for me as a peasant. I would have to do that just because that is the way to fully appreciate how much this book is delivering. Attempting to deliver, and I think delivering. So I'm just going through the chapter on Gröbner basis slowly. Just to show it's got a lot of problems. It's got algorithms. I love that. This would be a great analysis of algorithms for pure mathematics subject, course, self-teaching, self-learning course. Yeah, some applications. Yeah, heavy on the calculations. More pseudocode. Eliminating variables from systems of polynomial equations. The core of linear algebra. Lex order. Of course, by now you would have gone through Gröbner basis. More and more problems. Yeah, I really feel like going through and paging through the whole book. I think this is an amazing book. And yes, it is on my list of books that I would like to someday read. Not just something that goes into the collection. The correspondence between ideals and varieties. And this is an important theorem from the little that I know in algebraic geometry. The null theorem by Hilbert. As you can see, it's got great diagrams. Yeah, I'm gonna show less of the latter part of the book. I just wanted to give you a feel for what it looks like. And yes, you can see it's got a ton of problems. It does not have answers in the back. That is true. But some of them are numerical, and I'm sure with Sage Mathematica or Maple, you would know what the correct answer is just from punching it in. Okay, I'll just go to the back matter. Okay, so it's got errata. Bunch of errata. It's good that it carries it with it. Then the basics of abstract algebra that are needed for the book. And linear algebra. Then explaining how the pseudocode works. Then commands for Maple, Mathematica, and Sage, common commands, which of course can be easily found on the web. Some special purpose programs. Mentions other systems and packages like MATLAB. Then it's got some selected independent projects. Very nice for anybody who wants to branch off and do something special, maybe like over a summer. That's cool. And then your usual references and an index. Yeah. And I think, I'm not sure if I can zoom in well. Well, I'll zoom into this top part and end it there.